Okay, so welcome everybody. Thanks for coming. This is the week 2 webinar. And we have a pretty big plan today. So I'm going to share my desktop so you can kind of see my plan. And hopefully we'll make it happen and it'll go well. So let's share. And actually, I want to put number 10, which is the biggie. Okay, so the plan today, oh, sorry, no quiz. That was the old one. Is I'll start out with Q&A if you have questions, and that could be about anything, hopefully statistics, but or about the class, but anything else. If it's about something else, I may not be able to answer because I don't know everything, but I should be able to answer your statistics question. And so again, if you have any questions, just let me know. You just say it or put in the chat box, either way. You don't even have to raise your hand, just talk.
Hi, Larry. I have a question about the assignments. It's not listed anywhere, like what exactly they are, how to prep, or that kind of stuff. So any guidance would be helpful. I'm afraid to open it and start the timer until I know what it's about.
Okay, so it's a good, I think did you post in the Q&A? Someone did. That was you, I think. Yeah.
Yeah.
Okay, so let me re-explain that and I can explain in more detail. The assignments are chapter assignments. So there's 13 of them because there's 13 chapters. And what they are is they are computer graded questions, a dozen or so, it depends on the assignment, sometimes more, sometimes less. And with the regular assignments, first thing, they're not worth that many points, but you need to do them. You get zeros on them all, it's bad. So, don't just not do them. But what I'm saying is don't stress a whole lot. Does that make sense? That's one thing. So you don't need to stress about this. And one thing about the regular assignments is you can, if you get it wrong, if you get a problem wrong, you can retry it. So that's a big deal. So if you're going to do, like, say you're working on the chapter 2 assignment, because they're both due tonight. So hopefully you actually, I think they're due, no, tomorrow night. Yeah, it's hard because usually they're due on Sunday, but because last week it started on Wednesday, I gave you an extra couple days. So the idea is, let's say you're doing the chapter 2 assignment, then what I recommend is definitely watching the webinar now, and also watch the chapter 2 video and go to the textbook, the chapter 2 from the textbook, kind of, read through it. And then click on the assignment and go work on the problems. Because the problems are, again, it's not every detail of the chapter, but it's the main points of the chapter. And they test on the main points. That's the purpose of the assignments.
Kind of like a weekly chapter quiz, basically.
Yeah. Well, it's different than a quiz, though, because you get to retry the problems as many times as you want. Does that make sense? So it's more like homework than a quiz. Quizzes are very different because I want to talk about that too. So I'm glad you brought this up. So first, no stress. What I recommend is do it. If you get it wrong, then go back, read the book or watch the video, whatever you learn well with, and see examples that are similar to it and make sure you know how to do that. Then click try another one. And when you click try another one, it'll be very similar. Not exactly the same. The numbers will be different. Words will often be different, but the concepts are going to be the same. It'll be the same section of that chapter. Does that make sense? And then once you hit submit, then it's fixed. Then you're done. Like submit for the whole assignment. But if let's say you do, 6 of the problems and it's a 15 problem assignment, you leave and you come back, that's fine. And come back the next day, that's fine. Yeah, and it should remember that you've done some of them.
Can I ask a quick question?
Mm-hmm.
So I struggle with word problems in general. So this class is definitely going to be a challenge for me. I have a lot of learning disabilities, so it kind of sucks, but it is what it is. I have to get through this part. So I'm consistently calling my sister who's in the same class as us because I'm like, I don't know how to do this. I don't understand this. I feel like they're kind of stupid questions because as soon as she tells me, I'm like, oh, duh. Like, I should have known that.
It doesn't make it a
I'm-
stupid question. It just
Con-
means it's a question that you didn't have right in your mind at the time.
What was that? Would you ask me? I'm sorry.
Oh, that's not a stupid question. That's a question that you just didn't have in your mind at that moment.
Oh, okay. All right.
You know, the answer.
I just feel like I have like a lot of smaller questions to get to the bigger answers. And is that something I can contact you guys so I don't have to keep bugging her about it?
You can contact me. You know, I had those office hours. No one showed up today, but I was sitting on Zoom while, you know, kind of watching.
I almost went on and talked to you.
Yeah, if you got out, I would have been there. I watched a blank screen for an hour.
Oh,
You know,
man. Okay.
and I did some other things too because I can't sit for an hour watching a blank screen with like doing nothing. So I did some
Okay.
great. But
So these little questions people
yeah.
ask you, I don't want to keep bugging you with them.
And then the other person is Braulio.
Okay.
And Braulio, are you here? I don't have a list. Not everyone's showing in my, because I'm looking at my screen, but Braulio's around a lot. He has a lot of office hours. But I haven't, Monday through Friday, an hour a day. And but I'm definitely around. Sometimes it takes me a few minutes to get on Zoom because I finished my class at 45 after on Monday, Wednesday, Friday. So on Monday, Wednesday, Friday, if you come in exactly at 2:45, you may have to wait a couple minutes. So I apologize for that because I actually teach. It's about maybe 20 feet away is where I teach, but I have to erase the board and run to the computer and hit Zoom, if you understand. So.
Okay.
So if I'm a few minutes late, I apologize, but I'm definitely in my office.
Okay, thank you.
And if you're in Tahoe, I don't know if you're in Tahoe or if you're somewhere else.
I am, yeah.
So if you're in Tahoe, you can come to my office too.
Okay, cool.
The one rule, if you come to my office, you have to wear a mask.
Okay.
And that's not just for me, that's the college's rule. So,
Okay.
but it's a good rule. We're getting a lot of people with COVID and
Oh, for sure. I just came back from it.
yeah. So just let you know that is a requirement and we need that requirement.
Okay, thank you.
Okay. Other questions? Those are really good questions. Because that's like the purpose of these webinars is for us to do these interactive things. Because if we don't do the interactive, then you might as well just watch the chapter video only. So questions? I'm going to mute you and that might keep the vibration away. Okay. And by the way, if you have a question, just unmute yourself and then talk. So if there's no more questions, we talk more about what we're going to do. Today's probability day, chapter 3. It's funny. We only have one chapter this week. And it's probably 3 times harder than the 2 chapters combined last week. Just let you know that. So beware of chapter 3. It's a tough one. As somebody said, Amanda said, is that word problems are tough. And this is like all word problems. So that's why it's tough. So we're going to do probability. And then, am I going to win? Do you know what that was?
Scratcher, lotto.
That's the lottery, yeah. So am I going to win the lottery? Okay, we'll see. Yeah, that was Powerball. Okay, and the question, will I be a winner? We'll see. Okay, what is the probability of my ticket winning? Does that make sense? Yeah, I went fast because I don't think I want you to see the numbers because if I do win, I want to keep it anonymous. So no, actually, statistically, it's better not to pick your own numbers. And that's because if you don't pick your own numbers, you get random numbers. If you pick your own numbers, you get the numbers that you want, and you're more likely to pick the same numbers that someone else picks. Because people, it's a psychology thing, is that people tend to like the same numbers. And so it's better not to pick your own numbers because then you're less likely to have to share the money with someone else. Does that make sense? Okay, so it's all probability. Okay, and then I know this is going to look a little weird, and, or, given. Those are 3 big words in probability. We'll talk about how to read those and do those. Mutually exclusive, independent events, more words in probability. And then we'll talk about project 1. So the project's due in a little while. It's not due tomorrow, but don't wait till the last minute on this one. In fact, I read some of your comments that I want to start right away. So you'll be ready to start, in an hour or so. Okay, you won't finish it tonight, by the way. It is a tough project. I do want to also remind you that we're in an even week. This is week 2 of the class. And even weeks are different than odd weeks. Do you remember what happens in even weeks in terms of what you have to do?
Exam?
Yeah, exam. So this is week 2. And by Sunday, you have to do your exam. You definitely want to do the week 2 assignment or the chapter 3 assignment before you take the exam. And I'll let you know the exam for especially the week 2 exam. All I did is I grabbed your assignment problems, okay, which you don't see them all because it randomly grabs one, out of like 6 or something. So it's going to randomly grab out of a huge group of problems and give that to you. But the difference between the exams and the assignments is the exams are what we call exam style, which means you get only one try and you do it. And if you don't get it right, you don't get to try again. So they're different than the assignments. They're also timed. So you get an hour and a half to do that. As I've mentioned, if you've gone to the Disability Resource Center, you have a disability, by pretty soon you want to let me know so that I can give you extra time if your disability requires extra time. But if you don't tell me, or if the DRC doesn't tell me, I won't know. Does that make sense? So just in case you have, if you have a qualified disability, then I need to know what your needs are. So, and again, the Disability Resource Center will tell me if you do their evaluation, just let you know that. Okay, any questions about the plan today? Okay, so let's do probability. Okay, so by the way, probability is a little tough. It's a big deal in terms of the main thing with probability is that it's a definition. And what we want to do, for example, I like to bring in stuff if I can. You see what I'm holding? Right? There's a regular deck of cards. And if you haven't played cards before, I'm going to tell you there's 52 cards in a deck. There's ace, king, queen, jack, 10, 9, 8, 7, 6, 5, 4, 3, 2 are the values. And then for each of the values, there's clubs, hearts, spades, and diamonds. Got it? That makes 52 cards. And one of the things you want to say is, I just picked a card. Got it? And the question is, what's the probability that this card is an ace? Any questions on the question? So this is a nice, easy one. So what you do is you say, well, how many aces are there in the deck? Yeah, there's 4 aces in the deck. Okay. By the way, in our class, you're not responsible for knowing everything about cards, but I figure when I'm giving a webinar, I can talk about it, but I won't test you on, knowing cards. But it works well with probability, so I like to use it as examples. Okay, so there are 4 aces, and there's 52 cards. So it's very simple. The probability of an ace is 4 out of 52, or 4 divided by 52. Any questions on that particular example? All right, so just a note, it's sometimes you reduce a fraction, sometimes you don't. In this case, it's probably better not to reduce a fraction because it tells the story more to say 4 over 52 than 1 out of 13, because the 4 is the number of aces, the 52 is the number of cards. Often, though, you need to put it as a decimal, and hopefully you know how to type in 4 divided by 52 in Google or whatever you use for your calculator, and it'll give you a decimal. And read the instructions on your assignments, because sometimes we'll say, give 4 decimal places. And if it says that, then you round to 4 decimal places. Any questions on that idea first? Okay, so that was an example. Now let's look at the general definition. So the general definition of probability is that the probability of an event A, often we use A, sometimes you'll use E for event because E stands for event, A because it's like the first letter of the alphabet, but whatever, it's not important. Of an event A occurring is the number of ways A can occur divided by the total number of things that can occur. So for our example, the event A was picking an ace. There were 4 ways for that to happen. And there were 52 different things that could occur. Sounds easy? Probably sounds easy, right? Okay, what was my warning about this chapter? It's not easy, okay? This example was easy, but things get harder really fast. All right, so now let's do another example. Again, we're gonna do a lot of examples, and I'm gonna do another example. So now we got our cards. There's our beautiful cards. And now I'm not gonna pick a card. I'm gonna play poker, okay? And just standard poker. There's my poker hand, got it? Okay, and if you don't know, poker, I'm gonna give you standard poker, and that involves 5 cards. And the question is, what is the probability of getting a royal flush? Now, if you don't know what that is, that means that you have ace, king, queen, jack, 10 in your hand, at which they're all the same suit. So that could be spades, diamonds, clubs, or hearts. Okay, does that sound harder? All right, so the first thing is a good idea to do is go in here, and we have this poker hand. Uh-oh. There we go. So we have the poker hand, and in here, let's see if it allows me to do it. All right, I may have to do it this way. Let's try this. Just pop it right there, insert equation. There we go. That way I'll have a screen. So I'm going to go to fraction. So very important, if you look at the definition of probability, it's a fraction. There's a numerator and there's a denominator. Okay, let's do the easy part first. It may not even be that easy for you, but it's easier than the other part. And that is the numerator. What's the numerator? So that means that that's a number of ways to get a royal flush. Yeah, there's 4, because you can get a royal flush of spades, a royal flush of hearts, royal flush of diamonds, and a royal flush of clubs. So that's 4 on the top. Now comes a really hard part. Okay. Now the question is, how many different poker hands are there? So again, we have this deck of 52, and I'm going to pick 5 cards. Okay. The order at which you pick them doesn't matter, not with poker at least. But I got 5 cards. How many different 5-card hands are there in poker? Right? There's a ace, king, queen, jack, 10 of hearts. There's a 2 of diamonds, king of clubs, 3 of spades, jack of hearts, and 9 of diamonds. Okay. If you try to count them all, you will quit. There's too many. Does that make sense? So one thing you can't do is do what we did with the probability of just getting an ace, where you just, you just say, well, there are 52 cards. That was easy. But if you're picking 5 cards, that's not easy. Any questions on that? So, and this is the first time we're doing this. Actually, it's not. It's the second time we're doing this. Is that, do you remember what you do if it's too hard? If the math is too hard? No, you don't quit. You can quit, but you don't want to quit. you go to the calculator that I created. Remember, I created a calculator just for this class. So I'm going to go to the calculator. Do you remember this calculator? So this is the calculator we're going to be using, except for the project. The project we use that other calculator that I showed you last week. And I'll show you that again at the project time. And what we're going to do is going to go to what's called combinations and permutations. So it turns out that when you're talking about a poker hand, because order doesn't matter, this is going to be combinations. N is 52 because there's 52 cards in the deck. How many cards are we picking? 5. That's R. And then I hit calculate CNR, C for combinations, because order doesn't matter. Okay, and there's no way you could like try to list all the different possibilities. There's way too many, right? It's like almost more than 2.5 million different poker hands. So we get is 598,960 different poker hands. I'm going to copy that. Copy and paste is wonderful. And I can paste that in. Any questions at all on this particular example? If they tell you to, give decimal places, like a bunch of decimal places, then you can go back to the calculator, hit scientific calculator, hit 4 divided by, you get the divided by sign or hit the slash, and then I'm just going to paste in that number. Okay. Oh, you can't see what I'm doing? Really? Does that help?
I don't know. I feel like it's too large on the top part. Yeah, there we go. I can see a little bit more. I don't know why I can't see the whole screen.
Yeah, I'm sorry about that. Yeah, let me know if you can't see because I can see it. So I never know exactly what Zoom shows. So sorry about that. So definitely let me know. So you can see now. So what I did is I typed in 4 divided by that number, and I did copy and paste because if I type it, I'll probably like make a typo error. And it gives me, so is the probability 1.5 about? What do you think? Okay, the answer is no. So be very careful. One of the things is that probabilities can't be bigger than 1. You can't have more than 100% chance of winning. And they can't be negative either. You can't have a negative chance of winning. So they have to be between 1 and -1. So then you have to be able to read calculators. And it's this last piece. What does that tell you? That's 10 to the -6. That means move the decimal over 6 places to the left. Okay. And note, by the way, when you move to the 6 places to the left, the very first movement, it just shifts it over next to the 1. It doesn't put a 0 there. So there's only going to be 5 zeros before. Does that make sense? So what I'm going to get, let's write it out. That one. I'm going to copy paste. And now I'm going to move the decimals. So I'm going to put 1, 2, 3, just put a bunch of zeros and then just move the decimal one at a time. 1, 2, 3, 4, 5, 6. And the decimal place goes right there. Get rid of that decimal. Oops. And we don't need 2 zeros in front. And there's our probability. So what do you think? Royal flush is common or not common? Okay, yeah, very much not common. Okay, especially in 5-card stud, this is called, when you don't even get to like get more cards. Okay, by the way, I used to teach a class called the Statistics of Poker. Okay, it might have been called Mathematics of Poker, but it's basically the Statistics of Poker. Haven't taught that in a lot of years. Any questions on that example? Okay. So how about this one? Suppose you guess randomly on a 20-question 4-answer multiple choice quiz. Okay. So you probably had those kind of quizzes before. Find the probability of getting them all correct. So what's the probability of getting all 20 correct? So I want to let you know this is different. This is different than the poker problem. And the reason is with the poker problem, when I give a card out, okay, for example, this card's a 6 of diamonds, right? And I hand that to the person. Can the next card be a 6 of diamonds? Right, it can't. It can't. So with the poker example, we call that without replacement. Because that 6 of diamonds is not replaced when I grab the next card. I can't have a 6 of diamonds anymore. There aren't 52 cards left in my hand to deal. Do you see that? So that's very important. On the other hand, with the 20 question quiz, let's say you chose B for the first question. Could you choose B for the second question? Sure. So the quiz example is an example of with replacement. Any questions on that? And when you have with replacement, let me just write down in general. The probability, I'm going to write A and B, is equal to the probability of A times the probability of B when it is with replacement. And by the way, when it's with replacement, it's independent. And as you might guess, if it's not, then it's dependent, because that's the opposite of independent. Any questions on the idea? Okay, you could extend this instead of just 2 of them. We got 20 questions, but you do the same thing with the 20. What's the probability of the first one being correct? It's a 4-question multiple. It's a 4-part multiple choice. It's 1/4. So now I can write 1/4 as the probability of getting the first problem correct. Then I can go times. What's the probability of the second problem correct? 1/4. How about the third one? Not a trick question, by the way. Yeah, same. And the 4th and the 5th and the 6th. So just write ... times 1/4. The last one is also 1/4. What's a nice way of writing 1/4 times 1/4 times 1/4, repeated 20 times? Very basic math. Mm, 0.25 is just 1/4. It's 1/4 to the 20th power. Any questions on that? That's what power means. It means you keep multiplying that many times. The same thing. So by the way, I'm just going to go over here since I got my calculator. If I take 1/4, and I could take it to the 20th power, it's really small. So don't think you're going to get them all right. Turns out there's 12 zeros and then a 9. There's like basically no chance. Any questions at all on that example? I want to give you a big warning about this. I like to think of this like kickboxing. I don't know if I've told you, but the things I've taught are math, statistics, and karate. Those are my main things that I've taught. And there's a big difference between watching people kickbox and kickboxing. It's really, really hard to get in a ring and kickbox. And it's really, really easy to sit there and watch other people kickbox. Do you agree? So, and I mean hard as in like you have a big risk of injury and all kinds of problems. Okay. So math is like that too. So be careful about like watching me and understanding every step I do. That's not the same thing as being able to do it yourself. So make sure that you practice. Make sure you do lots of practice problems. And the assignments give you practice problems. All right. So actually not Mega Millions because it was a Powerball. What's the probability of me winning the Powerball? Okay. So I want to show you, by the way, real fast. There are two sets of numbers. I spent $4 and I bought two sets because, you know, I really want to win. So let's see what we can do. So the first thing is you have to understand the Powerball. So here is the Google. I went to Google, typed in California Lottery, and here's the Powerball. Okay. And the next draw is January 10th. It's tonight. So maybe I'm going to win. Okay. We need to know how to play. So I click how to play. And here's what it says. Okay. Pick 5 numbers between 1 and 69. And 1 Powerball number between 1 and 26. Okay. And then they pick numbers. And if they pick your numbers, you win. So I'm going to copy and paste into here, get the instructions. There we go. So you're going to pick 5 numbers between 1 and 69, 1 Powerball number between 1 and 26. So the first thing is I want the probability of winning. Probability, hopefully you know by now, is a fraction, right? So we're going to have a fraction. So let's make a fraction. All right. How many different ways are there for me to win? And when I mean win, I'm picky. I'm greedy. I want to win the biggie. I don't mean some little thing. I don't mean just $1 million. I mean the bigger one. How many ways are there for me to win? So how many different ways? That's what the numerator is going to be, by the way. That's the easy part, by the way. Okay. It turns out 2, because I said I bought 2 sets of numbers, right? Any questions on that? So the numerator is a 2 because I paid $4 instead of $2, and they gave me 2 sets of numbers. And I always do that. And I do that for the class so that I can show you a numerator that's interesting. Okay. By the way, I've been doing this for a lot of years now. Do you know how many times I've won? The big prize? Yeah, 0. Okay. If I did, you'll know I win because then we'll have dorms, because that's what I'm going to give $10 million to the college and put in some dorms for students to live in, or apartments, you know, because I think that'd be nice to have when I'm a multi-millionaire. Okay. Now let's do the denominator. So we need to pick 5 numbers between 1 and 69. And by the way, they have to be different numbers. You can't pick the same number 5 times. That's not allowed in the Powerball. Okay. So how do I figure out how many ways are there picking 5 numbers from 1 to 69? Do you remember how to do that? The hint is you can't just do it in your head or on paper. You need to actually do something else. Yeah, that's the calculator. So now I'm going to go back to the calculator. Now we're picking again. It is between 1 and 69, and we're picking 5 numbers. So I'm going to go N is 69. R is 5 again. That's just a random thing. And then I hit calculate. And there we go. So I can copy and paste. But I'm not done yet because I also have to pick a Powerball number between 1 and 26. Okay. And I'll tell you, I picked an 11 and I picked a 1, or at least the computer did that for me when I bought the tickets. Okay. So how many ways are there of picking one power number between 1 and 26? The hint is that's really easy. You don't need a calculator for that. How many choices do you have? Yeah, it's 26. And those are independent of the non-Powerball number. So that means I'm going to multiply, because independent means you get to multiply. So times 26. And that's the probability of me winning the Powerball. Now, let's figure this out. So I'm going to do the following. I'm going to copy that guy, go back to our calculator, and let's start over. So I've had, remember, 2 on the top. Then I'm going to divide by this guy. And what it gives me is 6.84459563 times 10 to the negative 9th power. So what do you think? Pretty likely or not very likely? Yeah, you probably don't want to go to my house and rob me so you can get my ticket, because your chance of getting robbing me, and remember, I'm also a martial artist, and your chance of robbing me and then actually making the many millions of dollars is very small. Remember that -9 means move the decimal over 9 places. So there's 8 zeros before that, 6 and 8. So there's almost no chance. Any questions on the Powerball example? So you shouldn't be surprised that I've never won the big lottery. I have won like $4. If you get the, I think if you get the last number right, then you get $4. Yeah, I'll take it. But I haven't won anything big. Any questions on that example? Okay, notice I'm doing lots of examples. If I go too fast, please slow me down, because I can't tell. You know, I only see a few of you actually, because if I saw everyone, I can't see my main screen. So please let me know, say something, or put in the chat box, slow down, or can you explain that again? But this is the Powerball example. Okay, here comes the next example. Okay, suppose that 20% of all students are taking stats at LTC, of all students taking stats at Lake Tahoe Community College are African Americans. And 40% of all stat students at LTCC are non-STEM majors. Okay. By the way, don't quote me on this. I made these numbers up. The only time you can quote me on numbers like this is if I give you a source. Okay. Otherwise, I make it up, and I make it up trying to make the numbers nice, so you know we don't have to like be scared of the numbers. Okay. If 22% of LTCC students are LTCC student non-STEM majors are African Americans, and you pick a randomly selected African American taking stats, find the probability that the student is non-STEM. Any questions on the question? All right, so here's my suggestion. I call this a wordy problem. Wordy problems are hard, especially for those who don't like word problems. But let me talk it over in terms of how to go about a strategy to figure this out. What I do is I reread the problem slowly. And every time I see a number, I write down what that is. So 20% of all students taking stats at LTCC are African Americans. Got it? So that tells you the probability of A for African Americans. The probability of A is going to be equal to 20%. It's always better to write as a decimal. What's 20% as a decimal? Yeah, 0.2. Okay. I like to use a 0 so you can see the point in between. Otherwise, it's hard to read. Okay. Then 40% of all stats students at LTCC are non-STEM. That's the probability. I'm going to call N for non-STEM. And that is equal to 0.4. Any questions on how I turn that sentence into probabilities? Okay, now the next sentence said 22% of LTCC stat students, non-STEM majors, are African Americans. So that's among the non-STEM majors, 22% are African Americans. So when you're saying just in this group, we have a percent, that's what's called a given problem. And the way we write that is probability of A given N, probability of African American given non-STEM. So that's how you read that. We're not told the probability of being both non-STEM and African Americans. We're saying amongst the non-STEM, 20% of them are African Americans. Any questions on reading that sentence or that phrase and writing it as a given problem? And that, by the way, is equal to 0.22. Any questions on that? Have I lost anyone? Because that's the hardest part so far. Okay. So then the question is, find the probability. So it says that if you randomly pick an African American taking stats, find the probability the student is non-STEM. So now if you're given the student is African American, we need to find the probability they're non-STEM. So that's the probability of N given A. And I write equals question mark. I always like to equal question mark because that gives me my goal. And if you don't know your goal, if you don't know where you need to go, it's very hard to get there. Okay. So if I tell you, tomorrow I need to go to that place that I'm thinking about, can you give me directions? Can you? What do you think? No chance, right? Because I didn't give you my goal. So if you don't know your goal, you'll never get there. So it's very important to write down this question mark. Write down your goal equals question mark after writing down all the things that are known. And that's a strategy for doing word problems that involve probability. His first step is write down everything you know in notation form, then write down what you want to know, and then use formulas to put them together. So here's a big formula, and that is the probability of A given B is equal to the probability of A and B divided by the probability of B. So I'm going to stop. This is an important one. Do you need to have it memorized for the exam next week on Sunday? Do you remember the rules on the syllabus? No, you don't have to have it memorized. You're allowed a note sheet, right? Note card. Put that in a note card. Okay, put that in your note card. Okay, you're allowed to have notes for this exam. Put that in your note card. And that, because I'm telling you, this is an important one. It's also a hard one. So you definitely want your note card. What you do have to have in your brain is an understanding of how to use it. Do you see? I mean, you can try putting that in your note card, but more importantly is understanding it. And you do that with practice, watching me and then practicing yourself. There's another formula that's important, and that is a little bit of math. If you take this formula that has this fraction in it, and you multiply the left side and the right side by the denominator, probability of B, you get the second formula. And that's the probability of A and B equals the probability of A given B times the probability of B. Any questions on that little bit of algebra? All right, so now we're ready to do the problem. I like to start out by writing my question mark. That's the probability of N given A. Then I can take that and I can use the formula. With the formula, it's nothing special about the letters A and B. Whatever letters there are for A and B, you just turn those right here and here. So probability of n given A is the probability of n and A. So instead of A and B, you write n and A divided by, so notice that A is the after the given sign. So that here the B is after the given sign. The thing after the given sign is the denominator, probability of A. Any questions on that? The next thing you can do, and this is, I think, hopefully obvious. So hopefully, you know, the probability of being an African-American and a non-STEM major is the same as the probability of being a non-STEM major and an African-American. It doesn't matter what order you speak those in for ands. It does for givens, but not for ands. So that's all I did is I switched the order. Then the probability of A and N, well, now I can use a second equation. The second says probability of A and B is the probability of A given B times the probability of B. But instead of a B, I have an N. So the probability of A and N is the probability of A given N times the probability of N. So I just replace the B with an N. And the nice thing is now I can take this and I have everything. Probability of A given N is right over here. That's 0.22. So instead of A given N, I write 0.22. Probability of N, that's over here. That's 0.4. So instead of probability of N, I write 0.4. And then the bottom, probability of A, that's over here. That's 0.2. So I put 0.2 on the bottom. And the rest, I didn't want to like bother you. The rest is basic calculator work. You can do it in your head if you're good at it, but better, use a calculator. And you get 0.44. Any questions on the process of this problem? So major warning, it's much easier to watch me do it than it is to do it yourself. So you want to practice these. Okay, and there are some in the homework assignments. There's some in the book.
Honestly, none of this makes any sense to me.
Which step?
Like,
There's a lot of steps.
all of
So
it, all
here's
of it.
probability of A. Probability of A is 0.2. All I did is read where it says 22% of all students taking LTCC stats are African Americans. And I used the capital A in African American, called that A, and 20% is 0.2. Did I lose you right there, or do you understand that piece?
Yeah, I mean, that makes sense.
Okay, so that's all that is. So what you do is you read this big long paragraph, and every little phrase you put into symbols. So similarly, 40% of the stat students are non-STEM. I used N for non-STEM. You got to pick some letter.
I mean, does non-STEM, like, what does that even mean? Do we need to know that?
No, but if I'll tell you,
Okay.
non-STEM means kind of, STEM means science, technology, engineering, and math.
Oh, okay.
So if you've never heard the word STEM, now you've heard it. That's not a statistics word, by the way.
Okay.
That's I think it's an education word. But now you know it. It's a good word to know, not for this class. It's just in general. You hear that a lot. STEM major is one of those majors. Basically, most of the non-STEM majors take this class. And the STEM majors typically take calculus.
Gotcha.
Okay, but not all. Okay. Some of them do take stats, as we see. Okay. So that's where that comes from. This is the harder one, the 22%. So 22% of the non-STEM majors are African American. So now we're going to say amongst the non-STEM, 22% are African American. So when we're saying amongst the non-STEM, that goes to the right-hand side of this given thing.
So we put 22% there?
The 22% is the answer of that.
Oh, okay. Sorry.
You see? This is the notation to say amongst the non-STEM, what's the probability of being African American? Okay. And then the question is, if you pick an African American, what's the probability of non-STEM? So that's backwards. Amongst the African Americans, what's the probability of being non-STEM? So that means we switch and an A, and we write probability of n given A because it's backwards. And that's the, we don't know yet because that's the question.
Okay.
And then these guys, again, you're not supposed to like know why they're true. You're supposed to believe me and have these written on a note card and know how to use them. But those are given formulas. And that's true in this class for most things we do, is that I'm just going to give you formulas and you just have to trust it. Okay. And I did take a whole bunch of like graduate level statistics classes that, where I needed to know these things and know how to prove them and all that. But so that means you can trust me. Sound good? That they're correct.
Yeah.
And if you don't, trust Barbara Lasky. She wrote the book and she's got the same formulas. Okay. So that's it. And then it's putting it together. All right. The next question. Let's see how much time I have. Yeah, I think I can do the next question. Suppose you roll 2 6-sided dice. All right. So I know a lot of you are in Tahoe. And when do you see craps? The casinos, right? And if you don't know, that's okay. They roll 2 dice in what's called a craps table. This is typically done. Okay, I will let you know, by the way, there's only one way, right? Nowadays to consistently win money being in the casino. Do you know how that one way is? There might even be a chance that one of you does it. Guaranteed to make money. I don't see anyone tell you. When I tell you, I'll say, oh yeah. Get a job there. Be a dealer. You'll make whatever, $15 an hour or whatever they pay. I have no idea what they pay. That's the only way you're going to make money. Just let you know. And if you think you can make money, you can't. And do you know whose fault that is partially? That's actually partially my fault. They hired me to make sure nobody won. And I helped them with changing the rules a little bit so that people like me can't win in the casino, okay, and consistently win. I used to be a card counter. So now I can't win. But by the way, I made money that way too. They paid me money to help them. Yeah, I already told you the secret to winning money. You work there and they'll pay you. You get a salary. Guaranteed. They will pay you, actually. They're really good about that. Never heard of anyone that didn't get paid for work they did. Okay, otherwise forget it. Okay, in the old days, you could have won, but also there's some life risking too, and that's a whole nother story. Okay, because I got threatened. Okay, so if you roll 2 6-sided dice, we're going to do this anyway. Find the probability the sum of the dice is a 5. So probability of the sum is a 5. All right, so this we could actually do. I'm going to make a little fraction bar. And I think I'm going to start with the denominator. How many different ways are there to roll 2 6-sided dice? How many different ways are there to roll 1 6-sided die? The hint is it's an obvious, easy answer. There are 6. Okay. So for the first die, you can roll a 1, a 2, a 3, a 4, a 5, and a 6. If you roll a 1 for the first die, how many different ways are there to match that with a second die roll of something? You can roll a 1 and a 1, a 1 and a 2, a 1 and a 3. There's 6 of those, right? And there's also 6 if you roll a 2 for the first one. So there's 6 plus 6 plus 6 plus 6 plus 6 plus 6. Or in other words, 6 times 6. Right? Because there's 6 ways for each, just multiply them. That's 36. How many ways are there of rolling a sum of a 5? Well, now you just count. You can roll a 1 and a 4. You can roll a 2 and a 3. You can roll a 3 and a 2. You can roll a 4, and a 1, and that's it, right? So there's 4 different ways of rolling, of getting a sum of a 5. And there's your answer. Any questions on that?
I have a question.
yeah.
Why isn't rolling a 2 and a 3 and a 3 and a 2 the same? Is it just because the order? Because
Yeah. And that's why I put 36 in the denominator. So
they're 2 separate dice. Okay. Okay. Thank you.
Yeah. So if we didn't care about the order, you turn out you get the same answer, but it's much harder to come up with that denominator. So I'm not going there. So we're going to say that you can do in either order. Okay. And for craps, those are 2 different things that can happen. Just trust me on that. Okay, I'm going to skip a bit. I'm going to go to contingency tables because I want to get to that example before, because we still have time, but I want to get to the project. So I want to do one big thing, which is contingency tables, and then we'll do the project. So I'm going to do it by example because I think that's the best way to do tables. If I do, a bunch of variables, will be really confusing. So instead, a survey was done. By the way, if it says a survey was done, I totally made this up, but a survey could have been done, asking LTCC transfer students where they plan on transferring to and what living situation they will be in when they transfer. And we're gonna pretend that COVID's not going to happen next year when they transfer. Sound good? Okay, I'm gonna hope that happens. My guess is you're all hoping to. Okay. And we have a table. So the first thing I want to show you how to read this table. So the first thing is when you have a table like this, for example, this number 8 means that there were 8 people in the survey who are transferring to a UC campus and are going to live with their parents. Okay. Whereas say there's 15 people that are transferring to UNR and are going to live in some other situation, not parents, not apartment. Okay. Maybe they'll be homeless, for example. That's neither, right? Okay. There's lots of others. Any questions on reading this table? All right, so then the question I have is find the probability that a randomly selected student will go to a UC campus or live in an apartment. Any questions on the question? Okay, now just to save us time, I did this, and that is there are 246 students in the survey. If I didn't tell you that, how would you find how many students that were there in the survey? It would take a while, but it's not hard. Yeah, you just add up all the numbers. And if you added all these numbers, you get 246. 43 plus 33 plus 19 plus 22 plus 34, etc., all the way to plus 11. And you get 246. Any questions on the question first? All right, so now I'm going to give you another formula. And I'm doing it with this example, but it works for any example. And that is the probability of being going to a UC campus or living in an apartment. And I'm going to use UC or A for apartment, is equal to the probability of going to a UC campus plus the probability of living in an apartment minus the probability of going to a UC campus and living in an apartment. Okay, so in general, by the way, the probability of A or B is the probability of A plus the probability of B minus the probability of A and B. That's the general way of saying the same thing. You can see that in the book. So that's an important formula. Another one you can put in the book, your note sheet, so that you have it like right in front of you when you're taking the exam. Any questions on that? Okay, the good news is with the contingency table, this is not that hard. All we do is we write these down. So probability of going to a UC campus. So what I'm going to do is I'm going to make a fraction. How?
I have a quick question.
Sure.
So is the probability of UC and apartment there because it's the opposite of UC or A? Like, it's sort of like because it's the and it will cancel it out, or why do we have to do that part?
All right, so here's why. So if you add up all the UCs and you add up all the apartments, you've double counted this 33. Do you see that? Because if I look at the UCs, that's 33 plus 8 plus 19. Got it? If I look at the apartments, it's 43 plus 33 plus 19 plus 22. And the problem is that if we just added those up, I'm double counting this 33. The 33 occurred in both of those, and they shouldn't be double counted because those people are just individual people. They're not doubles. Does that make some sense? So we subtract it off and it takes away the double counting. That's the reason why we do that. It's a good question, really good question, but that's the reason is by UC and NA, when you do those together, you're double counting the ands. So for the UCs, let's find that. So how many UCs are there? 33 plus 8 plus 19. 33 plus 8 is 41, plus 19 is 60. You could use a calculator. You don't have to do what I did, which is do it in my head. And the denominator is 246. That's the total number. Plus. Now we do the same thing for the probability of A. Probability of an apartment is 43 plus 33 plus 19 plus 22. 43 plus 33 is 76 plus 19 is 95. Plus 22 is 117. Any questions on that? And then the denominator is still 246. Because that's how many people there are in the survey. And then minus probability of UC and A. So now what I'm going to do is go back to fraction. And then we have UC and A. That's really easy because there's 33 of them. So that's just 33. And still over 246. Any questions on this? Okay, for time reasons, I'm not going to do the calculation, but hopefully you know how to use a calculator. Okay, you're allowed the calculator on the computer, that's the best. And that works. Any questions on this? Okay, let me give you a couple definitions that's what we're going to end up with. Two events A and B are called mutually exclusive if the probability of A and B is equal to 0. Okay, so the question is, are transferring to a CSU and living with parents mutually exclusive? And the idea, let me get rid of this 0, is if you count the probability of CSU and parents, that's going to be 34 over 246. Is 34 over 246 0? This is an easy question, by the way. Yeah, definitely not. You take 34 divided by 246, you don't get 0. So they are not mutually exclusive. Let me give you an example of something that is mutually exclusive in general. Let's suppose you're going to survey people and you're going to ask them what state they were born in. Okay. And you're also going to, we'll just do that. You're going to ask them what state they were going to born in. So is California and Nevada, are those mutually exclusive? What's the probability of being born in California and being born in Nevada? 0. You can't be born in both states. Doesn't make any sense, right? You're born in one of those places, maybe, but you can't be born in both. Does that make sense? So mutually exclusive means they can't simultaneously happen. It's a pretty easy idea. Okay. And then the final thing is 2 events are independent if any of the 3 are true. Probability of A and B equals the probability of A times the probability of B. Probability of A given B equals the probability of A. Probability of B given A equals the probability of B. So if one of those is true, they're all true. If one of those is false, they're all false, by the way. And again, there's some math involved. I'm not going to get into it, but you can trust me. So if you want to find out if 2 events are independent or dependent, then you pick the easiest of those 3, plug it in, and see what happens. So are living in an apartment and transferring into UNR independent? So let's do some computing. So let's check what is the probability of living in an apartment and given transferring to UNR. And you can look at that probability of living in an apartment giving transfer to UNR. Well, of the UNR people, 19 live in an apartment. And we're given that they're UNR students or they're transferring UNR, and how many transfers to UNR there are, that's this group, 19 plus 7 plus 15. 19 plus 7 is 26, 26 plus 15 is 41. So it's gonna be 19 over 41. And when I did 19 over 41 in a calculator, I got 0.4634, about. Probability of living in an apartment, we already did that. That was 17 over 46. Let me make sure you know how to do it. Put 117 over 246, stick that in your calculator, tell me what you got, put it in the chat box. So what is 117 divided by 246? Maybe a few decimals, that's all you need. 0.475. Are these the same? Probability of A given UNR, is that equal to the probability of A? This is an obvious question. No, they're not the same. So if they're not the same, if you don't get the same answer, then we could say they're not independent. We can also say they're dependent. Any questions on the idea of being independent? Any questions? Okay, let me give you what's next. And trust me, you're all going to want to write this down. And anyone know why? Secret word. The secret word for the webinar is fraction. Fraction. And that's because I try to give you a secret word that's relevant to what we're doing. And probabilities are fractions, right? So I figured that was a good secret word. So the secret word of this webinar is fraction. All right, so now what I want to do, I'm going to go to the syllabus and let's talk about project 1. So I wanted to have a good chunk of time for project 1. So we have to, maybe 20 minutes or so. Hopefully that'll be enough. All right, so first thing is I can scroll and I can read the projects. What was the first step for project 1? And a lot of you have already done it. That's a hint. Partners, yeah. If you don't have a partner yet, okay, and best is 3 in your group, then worry, get a partner. You need one. Okay, better is 3 people, but 2 is okay. 3 is much better. Okay, because would you rather have to do 50% of all the work or a little more than 33% of all the work? What sounds more fun? And it is a lot of work. So hopefully you'd rather do the 33%, 33 and a third percent. Okay, because if you have 3 people, you only have to do a third of the work. If If you have 2 people, you have to do 50% of the work. And you always have to worry about your partner dropping and then you're screwed. So it's better to have 3. Okay, so now let me read along. Okay, for project 1, students will collect quantitative data. Okay, so now we've gone through a bit, hopefully. What does it mean to be quantitative data? Yeah, numbers. Okay, and this has to be a survey. You're going to be doing a survey of people. Just let you know that. Okay, so first thing, I'm going to click on this project 1 link. And this Canvas, you have the same thing you can click on too. But it shows you the requirements for project 1. Okay. Okay. And so you have to think of a quantitative investigation that someone might contact you to have done. And I didn't write this out, but you need to have this. It must be a survey of people. So you're going to be doing a survey that's quantitative. What I recommend doing is coming up with your survey question and then ask your partner. And if a number doesn't come out of your partner's mouth when you ask the partner the survey question, then it's not going to work. Got it? Because it won't be quantitative. So that's a suggestion is, write down the survey question and see if that works. Okay. Then you're going to perform the investigation by conducting the survey. Got it? So you're going to ask people. Okay. And by the way, the reason why it doesn't talk about asking people is this was actually copied from last year. Why weren't people allowed to ask people last year? The hint is it really sucked. Yeah, COVID. I couldn't make people get near people, but now I can. But you have to be careful. So I want you to wear a mask if you're conducting a survey. Got it? And always better to be vaccinated. I can't force you to be vaccinated, but I can strongly recommend to be vaccinated. But definitely you have to wear a mask, okay? I don't want anyone getting COVID because you're conducting a survey for my class. Got it? So wear a mask. And, one of the fancy masks are better. Okay. So that's best. You could do it online too. Sometimes it's hard to get people to answer your question online. And then if you're doing it online, you don't have to wear a mask if you're emailing someone. Obviously, if you're alone and you're just emailing. So that's allowed. So you're allowed to do it by email also, but it's people that you're asking. Got it? Okay. And you're going to go and perform the investigation and produce a report on it as though you were handing the report to the person paying for your services. Now, you don't have to find a person to pay for your services, but you have to pretend you found someone to pay for the services. Got it? And in your project, you're going to have to identify who's paying. Okay, in theory, at least. Got it? Any questions on that? Okay, the purpose of the report is to make recommendations based on your findings. Okay, that's the whole point of the report. And the findings are going to be the statistics, by the way. So you're going to get statistics, and then based on each statistic, each individual statistic, you're going to make a recommendation to your client. So make sure you make recommendations throughout the paper. Okay, you have to include in your paper, as I mentioned, who hired you and why. Okay, and again, you make that up. It doesn't have to be, you don't really have to get paid, but who might hire you and why. Okay, so for example, it could be President Biden would hire you. That's okay. Even though I don't expect you to be able to contact President Biden and talk to him, because it'd be cool if you could, but good luck. But you could pretend you talk to Biden. Does that make sense? Or it could be that it was a counselor at the college, or it could be that it was the, CEO of, I don't know, Walmart or something like that. Okay. So there's lots of people that could hire you for that type of thing. Okay. Below are the items that the report must contain. So a description of the sampling technique that was made and how the technique was applied. So note this is a paper. You're going to write paragraphs. Are you conducting one paper P? I'm not sure what that means, what a paper P is. I have a feeling there's a typo there, but I'm not sure.
Can I?
Oh, paper per person. Okay, the answer is no. So there's gonna be one paper for the group. You're gonna work together and you better get along well because you're gonna get the same grade. Got it? And hopefully everyone puts a lot of effort into it, and contributes. Someone said, can I?
Oh, that was me. Can our sort of question, is it allowed to be like subjective? Like if I ask someone, how many cats do you have? And they say 5. But if I have a question on how many people come in to eat pizza at 5 o'clock, but it's more like not an actual, like, I don't know if this makes sense without giving her.
Let me tell you a problem with the second question. The survey question that you're going to ask a person is, did you come to eat pizza at 5 o'clock? Do you see that?
Oh, I see. So it's an exact yes or no, or exact.
That would be yes or no, and yes or no is not allowed because that's not quantitative.
Oh, I see.
So it has to be quantitative. So that's why you ask you ask your partner the question. That way you can practice.
How specific does the question, or like, how specific does it need to be? Because
it needs to be specific enough for your client.
Okay.
Remember, you're going to identify the client and you're going to decide what the client's needs are. And then you're going to write a question to help the client's needs. I also want to mention, because I don't think it all says so, but it's a good idea to come up with a project where there's more than 1 or 2 answers that people are going to say. So for example, do not ask the question, how many times have you been to Somalia? What's going to happen? Yeah, everyone's just going to say 0 and you're going to have a really boring project. You might get a 1, but I would never go to Somalia, that's for sure. Americans shouldn't go, they get killed. It's a bad idea. So unless I was in the military, which I'm not, by the way. I don't even know if our military has gone there. But the point is that find a question that has a variety of answers that you would expect. Does that make sense? Numerical answers. Okay, so if you were going to ask, how many times, we wouldn't ask how many times a week do you go to a pizza place. Instead, you would say, how many times did you go to a pizza place in the last year? And then you'll get much bigger answers and much more variety of answers. Do you see how that works? Because variety of answers is going to be better for doing statistics for this project. Does that help a little bit at least? Okay, so you must use either simple random sampling. Notice that's not like linked or anything because no one's going to use simple random sampling. And it's very hard to get that one right. It'll almost always be wrong and you'll lose points because remember, you can't get a list of all people in the world. Instead, you're going to use stratified sampling or cluster sampling, which we talked about last week, right, in the webinar. I also have links to it. So if you want to be reminded, you can always click on the links and it reminds you what stratified and cluster sampling are. Okay. Discuss any bias that might have occurred during your sampling technique. If you say there was no bias, I'm not going to believe you. Okay. It's pretty much impossible to have a sample of people with no bias. So that bias might be voluntary response bias, might be something else. Note that a bias involves misrepresentation of the population, so the sample data will not represent the population data. Okay, so in other words, based on the fact that you had bias, do you expect your sample mean to be higher than it should be or lower than it should be? Because if it doesn't affect the sample mean, then it's not bias, because it's all about the mean in this project. Okay, so the variable must be quantitative. I'm just restating that because it's a disaster if you don't have a quantitative variable. Okay, now comes an interesting one. The sample size must be greater than 30. What's the smallest sample size you're allowed to have? 31, exactly. So I want to let you know, this is going to be really important in further chapters. We're going to learn that for quantitative data, greater than 30 is like the hallmark of a good study. Okay. And if it's not greater than 30, you got all kinds of issues. So just trust me on that, which we're going to learn in a few weeks, why greater than 30 is the biggie. Okay. So for now, just trust me, you need to be greater than 30. And the good news is, check it out. If you did 33, for example, why am I saying 33 instead of 31? There's a reason. Yeah, right. If you each sampled 11 people, then you're going to get 33 and you'll be perfect. So that's not too many to ask. It's not too hard for me to ask you to ask 11 people each, right? Okay. So here's a big warning. If you think that you did a random sample, think again. It's very hard to do a random sample. Okay, maybe you did, but you better convince me because it's going to take a lot to convince me. So beware of that word random. You could do a stratified sample. That's good. And that's not too hard. You could do a cluster sample, also not too hard. Okay, notice cluster sampling is not one cluster. It's going to be multiple clusters. Okay, so maybe 3 clusters, for example. Why am I saying maybe 3? Yeah, each of you, there's 3 in a work, you could each do a cluster. Try to make it representative. Okay, so don't ask the same type of people for all 3 of you, but if you can each do a cluster, that'd be good. If you can do cluster, stratified sampling, again, that's a step-by-step process. Any questions on that? Okay, next, you're going to include all relevant charts. You must include a histogram. You must include a stem and leaf. And you must include a box and whiskers plot. Got it? You may include a pie chart, a line plot, etc., if it's relevant, but you don't have to. So it has to have those 3 charts. So another reason why you want a variety of answers, stem and leaf are not very interesting with only a single digit, because stem and leaves break up the digits, remember? So it's better if you can think of a survey that has answers that are 2-digit numbers, for example. Okay. All charts and statistics must be done using a spreadsheet program, not a calculator. I created a spreadsheet program just for this project. By the way, that spreadsheet program is used by dozens of colleges. So, it's become like the spreadsheet program for statistics. I don't know if I've mentioned, but I've been doing this a long time. I'm a major computer programmer, and my stuff is used by, millions of students. So this isn't just some, I did this, so you have to do it, but I will let you know it is really used by a lot. Okay. I spent a lot of my life answering questions from students that aren't even in this country. It's kind of interesting. Okay. Note this is not a comparison study. Okay. You're not doing a comparison study. It is a single survey question. The only reason why you would ask possibly 2 questions, any guesses? Okay, if you're doing stratified sampling.
Oh, if we had like quotas?
Yeah, if you're doing stratified sampling, then the first question is to establish what strata they're in. So that might be what is your race? Caucasian, African American, Hispanic, Native American, or some other Asian or other, whatever. That would be the only reason why you'd ask 2 questions. And I want to let you know, if you're going to do stratified sampling, that does not mean you're going to break your data up into different groups. What that means is that you're just making sure you've established the quotas. So you're not comparing, say, the African Americans to the Caucasians. You're just making sure that you have the right percentage of each in your group. And then when you put your data into the spreadsheet, it's just one column of data. You're not doing a comparison study. I'm saying this 4 times because it's one of the big mistakes people make. And then it's a disaster. Okay. So it's a single column of data. You're only going to have one sample mean, period. Do not compare sample means. You've made a mistake if you think you even can. Got it? Just to let you know, project 2, you're going to compare sample means. But that's not today. We're not talking about it. We're not ready to do that. You need a lot of statistics to be able to do that. You're not there yet. Okay. Good question. I'm going to get to that question in a little bit. Can you check in with you before you send it in? And I'm going to show you how. Okay. And it's not an absolute requirement, but it's a very strong recommendation. Okay. So if you have 2 of any particular statistic, you're most likely confusing the sampling technique with the data analysis. Any questions on that? Okay. You must use a spreadsheet, and you must copy and paste your spreadsheet result columns into the project to receive credit for this project. So that's an absolute necessity. You have to use a spreadsheet, and you have to prove that you use a spreadsheet by copying and pasting into it. Okay. And by the way, it's up to you whether you want to use, say, Google Docs, which is nice for, group projects, or you could use Microsoft Word. That's up to you. But you have to use, something. Any questions on that? I haven't clicked on this in a while. Hopefully I've updated it. If not, I'll re-update it. Yeah. So here we go. If you click on that, this will send you to a link. And this is a link that shows you, gives you instructions on how to use it. But if you click on this like really ugly link, this takes you to the spreadsheet program. Okay. And by the way, use this for when you go to it, it'll send you to the first tab. Use the first tab. The other tabs are for other stuff that we're doing in this class. First thing you do, go File. Then you go Make a Copy. And then give it a name. And hit OK. And then share the link with your partners. And that way you can see it together. Because it's a Google Sheets, which means you can look at it together and you can edit it together. I'm going to cancel it because I don't want to make a copy. But you guys are going to make a copy, so you have your own. If you don't make a copy, you can't add data. Okay, and then the first thing you'll do is erase my data. Like that, hit the backspace and erase it. Got it? Okay, so you have to use a spreadsheet, and this is the spreadsheet that's set up for this project. Any questions on that? Okay, so once we've used our spreadsheet, once you got to the spreadsheet, let's continue on.
I have a quick question. Do we need like a title page and a references page? Should
Yeah,
we be
you should.
citing any outside resources?
Definitely. So if you're going to use if you can use any resources, you should cite them. It is a paper. Okay, some of you will have resources, some of you won't. So if you're going to do, for example, stratified sampling, then you should cite the resource at which you found the percentage of each of your strata. Does that make sense? What I'm not picky about, this isn't an English class, so I don't care about like the technique of citing. I think I always forget there's 3 letters or something for the citation that people use. I'm not picky on that as long as you cite it. Does that make sense? If you just give the link, that's good enough. You must, and this is an absolute requirement, have your names on the project. Because only one of you submits it, but submit with all of your partners' names. Got it? Otherwise, I can't give credit to everyone. So that's like number 1. So that's in the title page. Does that make sense? That's easy. That's not hard. But don't forget, very important. Okay. All right. You also have to have an interpretation of each of the charts. So discuss what each chart says, okay, and doesn't say about the population. Compare and contrast the charts and state what the audience each chart might be best for. And talk about, again, throughout the whole paper, is how is your client going to use this chart? to make a decision. What decision will the client make after seeing this chart? You're going to give me a list of the summary statistics and interpretations of each. Okay. This variance, by the way, don't interpret the variance. Maybe I shouldn't even have that in there. But it should have the mean, standard deviation, and several others. Remember some of the others? We had the median, right? We had the first quartile, the third quartile. Do you remember those guys? Give me a Z-score for checking for outliers is a good way. Also, you should use either the empirical rule or Chevyshev's theorem. That was in the chapter video. I talked about those. So make sure you use one of those, not both, and the appropriate one. If you can use Chevyshev's, use Chevyshev's. If you can't, use the empirical rule. Okay, and you won't know until you look at a histogram to find out if you have a normal distribution or not, approximately normal. Okay, and what does the rule say about the population? Discuss how to use a Z-score for your study. Make sure you interpret all statistics in the project in the context of the study, rather than just list the definitions. So don't just give me a bunch of definitions. Talk about, hey, you have the first quartile. What decision is the client going to make after seeing that first quartile, for example? Okay. So I'll let you read through all of this, but it basically says that you should make recommendations, what I just said. You should also discuss how further studies could be done in order to delve deeper into the topic. So if you're ever working, as an employee, you always do that so you can keep your job. That way you have more job to do. They'll hire you again and say, I need more. They pay you more. So that's what you're supposed to do. Okay, and that might be, if we ask these other survey questions, we'll hear more information about our client. Does that make sense? That type of thing. I have feedback on Project One drafts that you can click on, and you'll see a bunch of feedback I've given in the past. I'll let you read the kind of font stuff. And the reason why I want you to double space it is that way I can put comments in. And I could do that through Canvas. If you don't double space it, I don't have space to put the comments. Does that make sense? So that's why I want it double space, so that I can put comments in. That's the only reason. Okay. And I'll let you read through the rubric and stuff like that. So a question was, can you run by your idea and your project with me? So let me first tell you what I recommend once you have partners and you've got your project idea, because you've talked about your project, is if you go to, so I got to move some Zoom and Windows stuff. If you go to discussions and you go to the Project One discussion forum, then what you can do is you can hit reply, type in your project idea, what your survey question is going to be, and how you plan on conducting the study. And I'll look at it and let you know whether it's going to work or not. And if it's not going to be perfect, and perfect is hard, by the way, that's okay, I'll let you know some modifications you can make to make it better. Does that make sense? To make it work better. Okay, occasionally I'll say, that's just perfect. It'll work perfectly. I look forward to reading your project. Got it? So that's one thing I recommend doing. And please don't do it the day before the project is due. That's not when you should start work on your project. Okay, that's something you could do this week, in fact. Okay, because you're ready. You're ready to do the project. And in fact, if we go to, so I'm going to cancel this guy. I don't have a project. Okay, I purposely don't have an example project because otherwise people just copy and paste. I don't want that happening. I want you having a project that you wrote. So instead, let's go back to the syllabus. And the project is due on February 6th. Okay, that's a long time from now, isn't it? Okay, so, don't expect to be finished tomorrow. You got a lot of time to do it. You shouldn't finish tomorrow. But don't start your project on February 5th. That's a big mistake. Okay, because doing a survey could take a long time. Working together with partners takes some time. This is a collaborative effort. The other thing is at least a few days. I think I put it in here. So the project is due on that February, which is a Sunday, by the way. And if you can email it to me by 8 a.m. the Thursday before it's due, or earlier is even better, then I'll read it and give you a lot of feedback. Okay, because I want you to have a good grade in your project. So if you give me the project, I'll give you a lot of feedback on where you need to improve. Do you see that? So there's two main times I'm going to give you feedback. One is when you send me your project ideas, I'll give you feedback on that. And the other is when you send me your draft of your project. Got it? So that's the Thursday before it's due. Again, this is all in the syllabus, so I'm not like, so February 6th should be a Sunday, if I'm right. Let's see, January, February. Yep, is a Sunday, February 6th. So the Thursday would be what? 3 days before that would be February 3rd, 8 a.m. But I want to let you know, I read them on a first come, first read basis. So if you, and it takes me a long time. I mean, these projects are usually like eight pages or so. I don't read that in 5 minutes. Yeah, that takes time. So if everybody sends it at 7:59 a.m. on that Thursday, then the one that sent it to me very last, it may take a couple days before I read it, just because it takes time to read. So I want to let you know that if you send it to me, say Wednesday in the early afternoon, you're probably going to get read a little earlier, or Monday, for example, on that day before, I'll read it right away. Does that make sense? So I do it on a first come, first read basis. I only read one draft because it takes a long time. If you send it over and over and over again, I don't have time to read it 10 times. So I read it once, but if you have questions about it after I've given you feedback, then you post in the Project One discussion forum and ask a question, I'll answer the question. Does that make sense? And that helps everyone because you can read things that went wrong or things that you have questions about and my answer, and then you'll be able to read other people's question answers and you'll see things that work. All right, so that's about all I have to say. I want to remind you again, this Sunday, your exam is due. You have to be done, give yourself 90 minutes to do the exam. Unlike the assignments, this is a 90-minute in a row time. And hopefully it won't take you even that long, but have it just in case. And I am going to stop my share. And I am also going to stop the recording.